In this video, we're going to divide these two rational expressions, and I'm going to show you that division of rational expressions is just the same as division for rational numbers, or fractions. So how do we divide fractions? Well, we multiply by the reciprocal of the second fraction. So it's going to be just the same when we divide rational expressions. So I'm going to copy down the first one. And then I'm going to put a multiplication symbol, since I'm multiplying, and then I'm going to take the reciprocal of the second fraction, or the second rational expression. So a mnemonic device that sometimes students use is copy.flip. It is also valid for rational expressions as well. Copy the first one down, put multiplication, because division of fractions turns into multiplication, and then take the reciprocal of the second expression. All right, now we're ready to do the multiplication, which we've seen already just means I need to factor all of these expressions and then cancel out any common factors that exist between the numerators and denominators. All right, so it looks like here I have a greatest common factor of 2. So when I pull that out, I have x squared plus 4x minus 21. The denominator looks like it's a quadratic that's ready to be factored. Looks like numbers that multiply to make -7, that add to make 6. So x plus 7 for one of the quantities and x minus 1. And here I have a greatest common factor of just an x, so 1 minus x. And down here it looks like I have a greatest common factor of 5, so x minus 3. So keep on moving here. I'm going to go ahead and finish factoring this one and just bring everything else down. So what two numbers multiply to make -21 that add to make +4? Looks like +7 and a -3. And everything else is just going to come along for the ride because there's no need to change anything else quite yet. Okay, we're at a point right now in multiplying these two rational expressions. They are completely factored, so now I'm ready to cancel any common factors that exist between the numerator and denominator. So it looks like an x plus 7 they share from top and bottom. Then it looks like an x minus 3 exists in the numerator and denominator. And then when we look at this x minus 1, we have up here a 1 minus x. So recall from a previous video, if we factor a -1 out here, this ends up being -1 plus x, or x minus 1. So then these are the same thing. Okay? So what do I have left now? That's all the common factors. So it looks like I have a 2 and an x and a -1. So I'm going to multiply all that straight across, and I'm going to get -2x. And then the denominator looks like it's just a 5. So it looks like the division, or I could say the quotient, came out to be -2x over 5. But of course, I also need to concern myself with values of x that we cannot use because ultimately they'll make the denominator of one of these expressions 0, or it'll make the expression undefined. Okay, so let's look to see what we factored out and what we canceled. So x plus 7, okay, so if I put a -7 in here, -7 plus 7 makes 0, and that would make division by 0, so I know x cannot be -7. Here I have x minus 1, so I know that x cannot be +1 because that would cause the denominator to be 0. And finally here I see that the x minus 3 canceled, so x cannot be 3. But I want to look at one more thing. All right? So let's go back to the original problem real quick. Because even though this turned out to be multiplication and I had x minus x squared in the numerator, it wasn't always like that. This originally came from a division problem where x minus x squared was in the denominator. So consider, if you will, for a second, what this factorization looked like. Right? So we had the x and a 1 minus x. We already excluded the 1 from the domain because 1 minus 1 is 0. But what we didn't exclude from the domain yet was if x itself equaled 0. Because looking at this rational expression, if x was 0, I would end up with 0 in the denominator. All right? So that means we also need to take into consideration that x cannot be 0. So here's what we have now whenever we divide these two rational expressions. Negative 2x over 5, and x cannot be these 4 values. Again, the 3 values here were the values that we excluded because of these denominators, but the 0 right here that we excluded was because of the original problem. The 0 would have caused this denominator to be 0, which then in turn would cause the expression right there to be undefined.